Access to reliable drinking water is commonly managed through centralized systems. In most residential settings, this includes municipal supply networks, groundwater wells, bottled water distribution, or filtration systems connected to an existing source. Each of these approaches carries its own requirements. Municipal water depends on regional infrastructure, regulatory management, and uninterrupted distribution. Private wells require land access, drilling, maintenance, and long-term groundwater availability. Bottled water introduces recurring logistics, storage space, transportation, and ongoing cost. Filtration systems assume the presence of a usable water source and require regular replacement of components. During periods of drought, infrastructure stress, or regional shortages, these systems can become less predictable. Declining water tables, delayed maintenance, supply restrictions, and distribution interruptions introduce friction. In off-grid or rural environments, these challenges are often amplified by distance, energy limitations, and dependence on external delivery. As a result, some individuals explore decentralized approaches intended to reduce reliance on fixed water infrastructure. These approaches often involve higher upfront effort, greater technical responsibility, or trade-offs between capacity and simplicity. Within this context, instructional products that describe alternative water generation methods have emerged alongside physical devices and commercial systems. Joseph's Well is a digital instructional product. It does not consist of a physical device shipped to the user. The product is delivered as a set of step-by-step materials that explain how to assemble a water generation system using commonly available components. The underlying concept described in the material is atmospheric water collection, a process that involves condensing moisture present in ambient air and collecting it as liquid water. The materials typically include written instructions, diagrams or schematics, and video demonstrations. The scope is limited to construction and setup guidance, rather than scientific theory, regulatory guidance, or performance certification. Joseph's Well positions itself as a do-it-yourself alternative to commercial atmospheric water generators. Rather than offering a finished appliance, it provides a method framework intended to be assembled, adjusted, and maintained by the user. Use of the Joseph's Well system begins with reviewing the instructional materials. The initial time requirement depends on the user's familiarity with basic tools and mechanical assembly. Most of the effort occurs upfront during sourcing of parts and construction. Interaction level during operation is described as low once the system is assembled. The system relies on electrical power to operate condensation components, which can be connected to standard grid power or alternative power sources depending on configuration. Repeatability is inherent to the design, as the system is intended to run continuously or intermittently based on environmental conditions. Output is dependent on ambient humidity, temperature, and airflow, though the materials focus on assembly rather than quantified performance expectations. Environmental needs include access to electricity, sufficient air circulation, and a location suitable for housing mechanical components. Maintenance involves periodic cleaning, inspection of components, and basic troubleshooting, all of which remain the responsibility of the user. Joseph's Well is most logically suited for individuals who are comfortable trading convenience for involvement. The product assumes a willingness to assemble equipment, source materials independently, and take responsibility for operation and upkeep. It may appeal to those who prefer instructional guidance over purchasing finished systems, particularly where cost sensitivity or customization is a priority. Individuals familiar with basic mechanical tasks or off-grid setups may find the format approachable. Conversely, those seeking turnkey solutions, certified performance guarantees, or minimal hands-on involvement may find this format unsuitable. The product does not remove uncertainty related to environmental variability or replace the need for monitoring and maintenance. The product is also less aligned with users who prefer centralized support, professional installation, or regulated consumer appliances. When compared to commercial atmospheric water generators, Joseph's Well occupies a lower-cost, higher-effort position. Commercial units typically arrive fully assembled, include warranties, and provide standardized output ratings. These benefits are offset by higher purchase prices and limited adaptability. In contrast, Joseph's Well emphasizes accessibility and modularity. It trades automation and certification for flexibility and user control. Depth of engineering and optimization is reduced in favor of simplified assembly and repeatable construction steps. Compared to traditional water infrastructure, the system described in Joseph's Well does not replace municipal supply or groundwater access. Instead, it functions as a supplemental or alternative method with different constraints. The product does not attempt to outperform large-scale systems. Its positioning centers on consistency of process, rather than guaranteed output or scalability. Joseph's Well exists within a broader landscape of decentralized water solutions that prioritize independence over convenience. It represents one approach among many, defined less by outcomes and more by the level of effort it requires. Its value depends on how much responsibility a user is willing to assume, how comfortable they are with variability, and how they weigh simplicity against involvement. As with most instructional systems, its role is not to replace existing infrastructure, but to offer a different balance of control, effort, and dependency.